Hello everyone, welcome to Source's classes. This is Tushar Shaw, and in this video we'll be continuing to solve the GATE 2021 questions that we were solving, obviously of chemistry CY. These questions we were solving since the last 4 videos, I guess. Okay, so in the last video we did up till question number 4, which was of the MCQ type of having 1 mark. Okay, so we'll be starting from question number 5 in this video. Okay. So the question number 5 is also a specific type of reaction. So let us do that. Okay. So the question I am not copying obviously because the question is already in your hand. I expect that you have the question paper in your hand. So I am just writing the mechanism. Okay. Um, okay. Just let me write down the question. It will be easy for me to like write also. So we are given firstly NaCl, then HNO, then HCl. Okay, so the product is required. So product, let us say we have question mark. Okay, so let us write down the mechanism. Okay, so the mechanism is um, O. So firstly, what would happen is from this step only. Let me write it. So this would attack this N over here. This Cl would be released from the system. Okay, so O in form of HCl. Okay, like HCl minus HCl would be removed in the first step. I'm not writing the first time, writing it directly. Okay, or we may write it like this. So minus HCl. So what would happen is ONO would be forming, and the other things would be remaining there as it is. Okay. Then we give H nu, okay, and dot of NO. Okay, so this dot of NO obviously is removed from the system, and this is nothing but the free radical NO of the like from the system is being released. Okay, so this is because of the presence of H nu. This type of free radical removal is possible. Okay, so the compound that will be forming is not the compound, the intermediate. Sorry. So O dot. Okay, and here is methyl obviously, methyl, the other things will be there as it is. Okay, now what would happen is this methyl will be having an H, so this H would be dissociating free radically. Okay, and this would be bonding with this, so giving us this dot, this Me, and we have this here, and here we will be having OH. Okay, now what would happen is, let me scroll it down. Sorry. Okay, then what would happen is this species would go and react with the NO that is being that was released in the system earlier. Okay, so the species now that will be forming is Me N double bond O, and here will be the OH and the other alkyl group, that methyl group, that are as it is. Okay, so what would happen in the next step is this would tautomerize. Okay, so tautomerization would take place. So here we will be getting double bond NOH, and here OH will be there as it is, and this alkyl methyl groups will be there as it is. Okay. So in the next step we give HCl. Okay. So what would happen is, um, so this obviously if we give HCl in the system, is a pointer. Yeah. So if we give HCl in the system, this would convert into CHO. Okay. Like if you hydrolyze, this C will be there as it is, and this NOH will be removed, and O will be attached, giving CHO. Okay. So here CHO, OH, and the other groups will be remaining there as it is. Okay. So this is the exact product that will be formed from this reaction, and obviously, yeah, this is the product. And obviously in the options you can see that option A, okay, option A has this product that we have calculated here. So option A is the correct option. Okay, so let us move on to the next question. That is question number 6. Okay, so the question asks that the reagents required for the conversion of hex 3-ine to E hex 3-ene. Okay, so let me just draw hex 3-ine. So we have, so this is hex 3-ine, hex 3-ine. Okay, so we have to convert this into hex 3-ene. Obviously E hex 3-ene. Okay, so here will be one double bond, E hexene. So what we require is, firstly, for this kind of reactions, like the most suitable, I am just telling you the answer, because obviously without the answer we cannot proceed with the mechanism. Okay, so for this kind of reactions, what we require is the most famous is the Lindler reagent. Okay, uh, I'm sorry, not the Lindler, the Birch reduction reagent. Okay, Birch reduction reagent, or you may say the Lindner reagent also, because both of them are same. Okay, so Li liquid NH3. This one was the exact, like this one would take out the proper reaction. Why? Because Li gives electrons for reduction. Okay, and electron is the sole thing that is required for for the trans conversion of ine to ene. And if like if H are given or any other species are given for reduction, then cis conversion would take place, but we require trans, so we are doing it via an electron. Okay, so we provide an electron over here. What would happen is a trans conversion would take place. Here would be the free radical. Okay, and then this species would react with the NH3, giving NH2 minus would be released. Okay, and here will be here one dot will be remaining as it is. Okay, this dot will be taking up another electron from the lithium system. Okay, this dot then will be converted into minus charge, and this minus charge will take another H from NH3, giving releasing NH2 minus ion, forming the species that we require, that is E hexene. Okay, so this is the exact reaction how we will be converting this. Now except for this Li we have the other reagents that are given is H2PD, which is option A, H2PD, H2PdBaSO4. This also gives H as the reagent, which is wrong. Bu2SNH, this has also H and Bu minus as the reduction reagent, so this is also wrong. And LiAlH4, we already know that it is a strong hydride producing reagent, so this is also wrong. What we require was a set of electrons. Okay, electrons would have converted the ion to the ene in transposition. Okay. Moving on to the next question that we have, that is question C, not C, sorry, question number 7. Okay, so question number 7 says, let us look at question number 7. So this question 7 says that in organic chemistry, um, so an organic compound exhibits the data that is given, M plus the mass spectroscopy data, M plus, M plus 2 plus, and M plus 4 plus to be 1 is to 2 is to 1. Okay, and so the singlet and the NMR data that is given is NMR data. We have a singlet at 7.49. Okay, and that is the H NMR spectrum. Okay, so H NMR, 1 H NMR. Okay. So firstly we have to identify the compound. So the structures that are given in the options, that is 1,4 dichlorobenzene, dichloro, 1,4 dibromobenzene, 1,2 dichlorobenzene, uh, and 1,2 dibromobenzene. Okay. So firstly, let us look at the NMR data. So from the NMR data, these two can be cancelled out. Why? Because these two show two sets of HNMR data, but we have only one set. The two sets being this as HA and HA, this one as HB and HB. Okay. Obviously, we can symmetrically divide this molecule from the middle. Okay, so two exceptional H, like two different chemical environmental H are present in the system. Okay, and similar for this case also. But in these two cases, you can see that if you divide this molecule can be divided into four parts. Okay, in this way. So the only edge that is present is here, and these there are four identical edge present in the system, and they give a singlet at 7.49. So this is option A and this is option B. So the answer would be among option B and option A and option B. C and D are just cancelled out because of the NMR data. Okay. Now let us look at the mass spectrum data. Okay. So obviously mass spectrum data, the this one this for the let us draw the graph for Br and Cl2, the Br2 and Cl2, the mass spectrum data. Okay, so two types of plots will be obtained, and this is for the Br2 and this is for the Cl2. This one is M plus, this one is M plus 2 plus, and this one is M plus 4 plus. Okay, here is also M plus M plus 2 plus M plus 4 plus. Okay, so obviously you can see that the intensity ratio is 1 is to 2 is to 1. So so for the Br2 system. Okay, so because of the presence of 2 Br, we have this kind of plot is obtained, that has the ratio 1 is to 2 is to 1. And as the question the ratio, the intensity ratios for the this kind of species plot is 1 is to 2 is to 1. Therefore this option, that is the 1,4 dibromobenzene, would be the correct answer. Okay, so option B here would be the correct option. Okay, so yeah, so this was it. Let us move on to the last question of this video. So we did quite a lot of organic questions. So this question is an inorganic one. Okay, so the reaction of LiAlH4 LiAlH4 with one equivalent of Me3 NHCl gives a tetrahedral compound, which a tetrahedral compound we don't know. So which reaction with another equivalent of Me3NHCl, okay, this compound is tetrahedral obviously, gives compound N. Okay, this compound N. So we have to find out the compound N and the geometry. Okay, and its geometry. Okay, so let us firstly write down the first reaction that is occurring. So the first compound that is formed is AlH3N Me3N. Okay, so this is the first compound which is tetrahedral obviously in comparison to like in the presence of obviously aluminium. Okay, this compound is sp3 hybridized and therefore tetrahedral. Now what would happen is AlH3N Me3 whole N when reacted with Me3 whole N HCl, again what would happen is this compound is formed AlH3N Me3 whole N whole 2. Okay, this has five bond pairs, and the hybridization is sp3d2. Okay, so the structure for this species would be Al and N Me3 N Me3, here H would be there, and here H and H would be there. So this structure is the tetragonal bipyramidal structure, or the TBP geometry. Okay, I'm sorry, not tetragonal, triangular bipyramidal. Tetragonal bipyramidal is octahedral structure. Okay, so triangular, because this is a triangle formed, and so triangular bipyramidal, which is TBP geometry. Okay, so the reason for this kind of structure is formed because obviously the let us say the bulkier groups are kept in the equatorial plane. Okay, this equatorial plane, the bulkier groups are kept because the angle between the axial and the equatorial is 90 degree, and the angle between this two equatorials is 120 degree. So they are more safe from steric repulsion in the angle 120 degree than in 90 degree. Okay, so this is the reason why they are kept in this kind of equatorial position. Okay, so in the options you can see that this option that we have written is for the is given in option C. The compound is given and the trigonal bipyramidal structure is given. Okay, so option C here would be the correct option. Where is the pointer? So option C here would be the correct option. Okay. So let us wrap this video up. Obviously, this was a quite a long video. Okay, we did solve a lot of great questions. So obviously, so in the next video onwards, we'll be taking from question number 9. Okay. So so thank you guys for this video. I'll see you guys in the next one.